Hello, everyone. My name is David Gomez, and I am Corporate Development Staff in AEI Textiles, the Advanced Textile Materials Cluster of Catalonia that is located near Barcelona. AEI Textiles is a cluster with a non-profit association structure that integrates Catalan companies in the advanced textile materials value chain and other innovation support organizations. Its main objectives are to promote research, development, and investigation, mainly in cooperation, to promote at all levels cooperation within Catalan advanced textile materials sector, and to promote the cluster and its members at the international level. According to our expertise in eco-design projects and initiatives implemented by our companies, for the CleanTex course, we have prepared the second part of the Unit 3, Eco-Design for Circular Economy. So if you are ready, we can start by revising today's content and talk about what circular economy is. In the module 2.3, man-made fibers with low environmental impact, we are going to discover the main characteristics, properties, and uses of the most well-known man-made fibers that are low environmental impact. The content of this module is divided in two different topics. Firstly, the natural polymer-based fibers, and secondly, we will talk about synthetic polymer-based fibers. First of all, let's make a general view of the fibers world. Textile fibers can be organized regarding its chemical structure, source, utility, etc. The most extended classification is the one obtained when separating the fibers by its source, dividing them into two main types, natural fibers and man-made fibers. Depending on their origin, natural fibers can be subdivided in other groups, and the same happens with the man-made fibers, which can be organic or inorganic, depending on the chemical structure. Organic polymers are distinguished from inorganic polymers because of the presence of carbon atom in the main chain. In this module, we are focusing on the man-made organic fibers, and these include man-made organic fibers coming from a natural polymer and man-made organic fibers coming from a synthetic polymer. Polymer is a material constructed of smaller molecules of the same substance that form larger molecules. The polymers are any of numerous natural or synthetic compounds of usually high molecular weight and consisting of up to millions of repeated linked units, each a relatively light and simple molecule. Natural organic polymers include polysaccharides or polycarbohydrates, such as starch, and cellulose, lignin, and proteins. Synthetic organic polymers include polyethylene and polypropylene, polyamides, polyesters, and polyurethanes, among others. And now let's talk about natural polymer-based fibers. The use of organic chemical fibers from natural polymers is considered a valuable eco-design strategy because it allows to incorporate high percentage of recycled fiber, post-consumer, for example, into a new yarn with better physical properties than a mechanically transformed recycled yarn. In addition, the process allows the use of a wide range of material, some of which are considered waste. That is, if they were not used, they would go to the landfill. However, from an environmental point of view, it is always important to take into account the production process, since it usually involves the use of the chemical products, which could compromise the fiber's environmental footprint. In any case, advances in the field are proposing new solutions to that problems by changing the process. Turning them into a closed-loop ones, the chemicals using ones less harmful for its users and the environment, and raw materials coming from certified sources or being recycled. Now we are going to see some examples of these fibers. And let's start with chitosan. Chitosan fibers are made from chitin, which is extracted from shrimp or crab shells, a waste of the food industry. Some of the most important characteristics or properties of chitosan are: it is a safe material since it comes from a natural and more specifically from food. It is biocompatible, so it's not toxic or allergenic. It is biodegradable. It promotes healing by acting on autoimmune system and accelerating the generation of epidermal tissue. It also improves body immunization against possible diseases. It is antifungal and antimite properties. And finally, it provides softness and comfort to garments. In spite of these goods properties, its low performance manufacturing process makes the fiber expensive, and in addition, its mechanical properties are low. In order to use it in yarns, it must be blended and with other raw materials such as viscose. Due to their characteristics, the main applications of chitosan are for underwear, also especially in medical cases, toiletries and fabrics for decoration such as pillow and towels, because of its antifungal properties, and also in general clothing due to the softness and comfort of the fiber can give. Sports is one of the areas that chitosan is useful as well, again due to its antifungal and antibacterial properties. And next fiber we are going to talk about is polylactic acid. Polylactic acid fiber is also known as PLA. Is made from a lactic acid obtained by fermenting cornstarch. As it is not obtained from a byproduct but from a food source, the use of these fibers causes some controversy. Although it is compostable, polylactic acid is quite durable in most of applications. In fact, PLA does not readily degrade unless it is exposed to a high humidity and elevated temperatures above 60 Celsius degrees, which results in a rapid decomposition of the fiber. Thus, for most applications, its durability is acceptable or good. Those fibers offer a comfort and an isolation comparable to natural fibers and can easily care just like synthetic fibers. They can be mixed with wool, cotton, viscose, both in knit and open work. And some of the advantages they can offer are the following: low humidity absorption, low flammability, low resistance to abrasion, biodegradability, resistance against ultraviolet radiation, toughness, prevention of bacterial colonies formation, and its touch is similar to cotton. PLA is fully biodegradable and biocompatible, which makes this fiber attractive for medical applications like wound dressing. The fiber is also useful as an eco and people-friendly alternative to existing textile fibers for industrial and consumer apparel applications such as outdoor furniture, automotive interior fabrics, active wear, shoe leggings, and disposable products like diapers, wipes, either at 100% or in blends with natural fibers such as cotton. And now let's focus on alignate. Alignate is a natural polymer organic chemical fiber obtained by alginic acid metal salts. It is obtained from some algae and it is extracted from them by a specific treatment. Alginate fibers are made from sodium alginate, which is a natural polymer extracted from brown seaweeds. Over the last 2 decades, alignate fibers have become well established in the wound management industry, where their ion exchange and gel forming abilities are particularly useful for the treatment of exuding wounds. In order to deliver functional performance for advanced wound management products, many improvements have been made in recent years to enhance the absorption and gel forming capabilities and antimicrobial properties for alignate fibers. In addition, attempts have been made to use alignate fibers as carrier to deliver zinc, silver, and other active ingredients that are beneficial to the wound healing. Alignate have the following properties. It is biodegradable. It can absorb, the capacity of absorption is up to 20 times its weight. It has a good resistance to solvents, good phytosanitary properties, late ignition, and low mechanical resistance. Alignate has found numerous applications in biomedical science and engineering due to its favorable properties, including biocompatibility and ease of gelation. The main applications of this material for the manufacture are medical hygienic products, due to the absorption capacity it has, but also decorative fabrics, underwear, and socks. And now let's talk about not only fiber, but a group of them. Cellulose fibers are fibers obtained through a chemical process from a polysaccharide known as cellulose, which at the same time can be obtained from a bark, wood, or leaves of plants, or from other material that contains this molecular chain. With this process, we can also recycle cotton biochemically if we undo its structure and rebuild it. There are different types of cellulosic-based fiber, depending on the chemical process used to make them and also to the source of the cellulose. Each one has different characteristics specifically regarding its environmental performance. Regarding the cellulose fibers, have a lower environmental impact since the products made by them can be used in recycled fibers, and they are biodegradable because their cellulosic nature. Although the process for obtaining them are different, some are more respectful toward the environment than others. In general, items made from regenerated cellulose are comfortable thanks to their ability to absorb moisture, which is superior than other cotton or silk. Which cellulose fiber names come to your mind right now? I am sure you have heard about viscose, modal, rayon, lyocell, for example, right? Although they are quite similar, let's differentiate them. First one, rayon, is a regenerated cellulose fiber, usually derived from wood pulp. Rayon is usually made from eucalyptus, but any plant such as bamboo, soybean, cotton, etc. can be used. Viscose, modal, lyocell, and bamboo are different types of rayon. Next, viscose uses regenerated cellulose polymer obtained by the viscose process from wood and vegetable fibers. Its process uses a large amount of chemicals, which is very harmful to the environment when released into effluents. However, we can find few sustainable options available in the market that worth mentioning, such as Enka, Eastman, Naya, and Ecoveru. Modal production process beech trees with a process similar to the one of viscose. Lenzing sells modal under the name of Lenzing modal and only uses trees from sustainably exploited forests, PEFC certified, and uses environmentally friendly bleaching method. However, modal is produced by many other manufacturers that do not necessarily use sustainable processes. Next one is lyocell. It is much more environmentally friendly rayon manufacturing process than it is modal and viscose relatives. Lyocell is manufactured in a closed-circuit loop system that recycles almost all the chemicals used. Lyocell is the generic name of the manufacturing process and fiber. Tencel is the brand of lyocell marketed by Lenzing AG. Tencel is made from eucalyptus from PEFC certified forests. Eucalyptus grows quickly without the use of pesticides, fertilizers, or irrigation. And finally, Cupro. It is an artificial cellulose fiber made from linen cotton or cotton waste. To have the yarn ready for weaving, the extracted cellulose is soaked in a bath of chemical solution called cupramonium. The whole process is performed in a closed lab circuit. Cellulose fibers are cheap to produce, and its versatility fabric used for clothing items such as blouses, dresses, and jackets, and around the home in the carpets and upholstery as well. Now, let's see another kind of fibers, milk fibers. 2 million tons of milk are disposed of around the world in a year. Milk protein fiber is manufactured from this waste through bioengineering technique. Milk fiber was invented in 1930s in Italy. It was manufactured from milk casein to complete with wool. Casein is obtained by the acid treatment of skimmed milk. The casein coagulates as a curd which is washed and dried and then ground to a fine powder. Casein is dissolved in caustic soda solution. The solution is allowed to ripen until it reaches suitable viscosity and is then filtered and deiterated. Milk fiber is made 100% renewable resources, and thanks to an eco-efficient production technology, it presents significant advantages. It is biodegradable, it contains antibacterial fiber, and it is ideal for people who suffer textile allergies. The fabrics are made from milk fiber, provide high wearing comfort and a silky feel. And milk fiber resembles wool in having a soft and warm handle. The production process allowed the obtention of 1 kilo of fiber each 5 minutes and has a high level of water saving, 2 liters for 1 kilo of fabric, compared to the cotton production, which is 20,000 liters for 1 kilo of fabric. This process does not have a significant or pollution wastage, which is very relevant. The uses of milk fibers go from clothing to towels or bed sheets. And now it's soy fibers turn. Soy fibers are made by distilling soy protein and refining it. Then an auxiliary agent and biological enzymes are added, making the spatial structure of the protein change. Polymers are then added to the liquid mixture and temperature is applied. The threads are extracted by wet spinning technology. The main properties of the soy fibers are biodegradability, that it can be dyed using acid and reactive dyes, especially these last ones can give it a very good and bright color, good results to perspiration and light fastness, good hygienic and functional properties, has a good affinity with the skin of the human body. It has, at the same time, the ability to absorb moisture as cotton, which gives it a high level of comfort. It has the same ability to, it does not shrink, finally. The main applications for soy fibers are for home textiles, children clothing, underwear, outwear, and sportswear. And now about elastomeric fibers. These ones are those that are able to elongate themselves up until 400% and recover its original aspect rapidly and repeatedly. The most well-known brand of elastomeric yarn is Lycra, from the company Invista, a long chain of polyurethane. Rava can be transformed into elastic fiber. Rava natural fibers are produced from the salvia extracted from the tree called Hevea brasiliensis, and the rava is produced after its coagulation. The logical application for this fiber is in fabrics where a high elasticity grade is needed, such as the sports clothes or lingerie. And this is the last natural polymer-based fiber we will talk about. Now it is time for synthetic polymers. The use of recycled polymers reduces the dependence on fossil raw materials. We are going to give you some information about recycled polyester and polyamide. Recycled polyester, also known as rPET, is made by melting down existing plastic, PET, and spinning it back into new polyester fiber. While much attention is paid to recycled PET, made from consumer discarded plastic bottles and packaging it can also be made from post-industrial materials. Some points in favor to use recycled polyester can be: recycled polyester gives a second life to a material that is not biodegradable and would otherwise end up in the landfill or in the ocean. And its manufacture requires fewer resources. Recycled polyester is almost the same as virgin polyester in terms of quality, but its production requires 59% less energy compared to the virgin polyester. Still, we have negative or to be improved aspects. Let's talk about them, because many garments are not made from only polyester, but also from a mixture of polyester and other materials. In that case, it is much more difficult, if not impossible, to separate and recycle them. The PET recycling process also affects the environment, as the chips generated by a mechanical recycling can be different colors. In these cases, it is necessary to use chlorine-based bleaches to obtain subsequent uniform dyeing, and its way require a high use of water, energy, and chemical products. The recycled PET produces microplastics as well as other synthetic fibers do. It's difficult to limit the applications of polyester. I bet that every one of us is using polyester right now. So recycled polyester can be used at the same items as polyester does. In case for recycled polymer, the case for recycled polymer is quite similar to what we have explained about polyester. The raw material source for recycled polyamide, PA, uses to be old finishing nets and carpets, as well as waste from manufacturing industry. Some companies have patented a recycling process that transforms post-industrial technical textiles like airbags into premium plastics. This technology offers new products that are more ecological and with similar performance to those made of PA. And again, the use of recycled polyamide can be assimilated to those of non-recycled polyamide. Thank you for your attention. I hope you have learned a lot, and see you in the other lessons. And in case you need them, don't forget to consult the reference we have used to prepare this module. Bye.